Hello, and welcome to our second in this series of videos that are going to help you pass your high-stakes math test. And we're starting out in the beginning of this series with just some fundamental basic concepts that, if understood, other things are going to be easier. So the second thing that we're going to look at is multiplication of fractions. Now, some things that were true in elementary school when you only knew about whole numbers are no longer true when you know about other kinds of numbers. And one of those things is that multiplication results in a bigger answer. That kind of gets ingrained into us in the earlier grades because we're taught that multiplication, the mental model for that is like 2 times 3 would mean you have 2 blocks in a group and you've got 3 groups. And that model can only result in a bigger answer. But once you have different kinds of numbers, that's no longer true. And sometimes we just internalize that, and we don't understand why we have anxiety when we're doing math. But it's often because of the underlying assumptions that we don't realize have expired. In multiplication, opposite means the number flipped upside down. They also call this the reciprocal. And if you don't have a fraction, so you really can't flip it upside down, you can always put a 1 under it, and then you can flip it upside down. So the opposite of 1/5 is 5 over 1. The opposite of a third is 3 over 1. The opposite of a negative number is a negative number because all you're doing is flipping it upside down. You're not changing the sign. So the reciprocal of negative 2/3 is negative 3/2. Okay, here's a rule that's an important rule. Don't ever divide. Change division to multiply the opposite. So 3 divided by 1/2 is 3 times 2 over 1. The opposite of 1/2 is 2 over 1. You flip it. Change divide to times and multiply the opposite. 4/5 divided by 8/3 is 4/5 times 3/8. So you don't need to know how to divide fractions because you're never going to do it. You change division to multiplication and multiply by the opposite. So you just need to know how to multiply fractions, and that is easy. You multiply straight across. Now, of course, we could reduce that at many different points, but the point here is just to know how to multiply fractions straight across. So what we covered here is you need to realize that multiplication gives you a bigger answer is an idea that has expired. Now that you know about numbers other than the counting numbers, that's no longer true. With fractions, you can multiply and get a smaller number as an answer. In multiplication, when we say the opposite, we mean the number flipped upside down. 2 fractions are opposites if one is the other one flipped upside down. And if you've got a whole number, put a 1 under it if you need to get the opposite of it. Don't ever divide. Always change to times the opposite. And multiplying fractions, you multiply straight across. One way to get better at math is to become a pattern recognizer. Look at these 2 lists of the basic ideas from our first video that went over subtracting negatives, and from this video on dividing fractions. Note the patterns. They both have an expired idea that gives you anxiety if you don't realize it. They both employ the idea of opposites, but opposite is relative to what operation it is. In multiplication, the opposite of a number is the flip of an upside down fraction, and in addition, the opposite of a number is the number with the opposite sign. But they both have the idea of opposites that play an important role. We don't want to divide. We want to change it to multiply the opposite. We don't want to subtract. We want to change it to add the opposite. And there, the word opposite, the definition of opposite depends on which operation you're doing. And then once we have that, that's where the pattern is. Then you just need one rule for how to multiply fractions and one rule for how to divide or how to subtract. And when you look at it this way, you don't need to remember a whole bunch of rules. The math books that I've taught out of have given just countless steps and rules about when you're adding two positive numbers, count to the right. If you're adding a negative and a positive, count to the left, or subtract the absolute value of the, just on and on, to where I've looked at that and thought, I could never remember these rules. But if you look at it this way, where you got the pattern of change subtraction to addition and then just think of money, you don't need 15 different rules for how to subtract with integers. When you start recognizing these patterns, then some of the things that you learn in math that you might have thought were just some one-off thing they were just throwing in, like identity element, like you needed that for a test, but why is that even in here? Well, when you start understanding these patterns, it makes more sense, the important role of an identity element. In multiplication, the opposites multiply together to make 1. And 1 times anything doesn't change anything. And in addition, the idea of opposites are what add together to make 0. And 0 plus anything doesn't change anything. See, there's more of this pattern recognizing here. And so the identity elements are relative to an operation. The identity for multiplication is 1. The identity for addition is 0. You need to firmly understand the idea of opposites, because when you start doing algebra, you need to eliminate things in order to solve equations. It's really just steps to eliminate things until you've got nothing left but the answer. And you get rid of numbers in the problem by multiplying by their opposites so you can get ones, because you can just throw the ones away if you're multiplying and not write them. And with addition, you add opposites in order to move things around and eliminate them, because when you add opposites, you're annihilating things out of the problem. So algebra gets a lot easier if you look at addition and multiplication this way.